Very good day, dear students. Here am I again with the next session. That is the session 17 of this robotics course. I am a faculty Shomodeep. Let's begin with the session. So here it is, session 17 of chapter 17 of class number 17 that we will be undergoing today. And today we are going to learn about something different called constant. Okay. So what are constants? The constants in Arduino programming, they are defined basically something as predefined expressions, right? So if we define an expression prior to using it, okay, prior to initiate the program, that's called the constants, okay? It makes the code easy to read, and the constants in Arduino are defined as the logical level constants and pin level constants. We'll be going into details into it, okay? But what it does, try to understand what is the purpose of a constant in Arduino code to make the code easy to access, easy to read, okay? All right. What you are doing, basically, if anybody sees the code, it will not be a complex structure for them, complex set of instructions and everything for them. Okay. What you are doing is making it very easy. Okay. This is the thing. All right. Now, logical level constants. Okay. The logical level constants, they are true or false. Okay. Logic based. The value of true and false, they are defined as 1 and 0. Of course, in binary structure, when the logic is true, you will get an output of 1. When the logic is false, you'll be getting 0. Okay. In that way, it is defined. Okay. Now, any non-zero integer is determined as true in terms of Boolean language. What is Boolean language, dear students? Boolean algebra, if you know, okay, it basically operates on the version of 1 and 0. So either you get 1 or you get 0. Okay, and there are definite rules. If people from electronics or CSE or IT background, they will be knowing Boolean algebra. Okay, very interesting actually, very interesting subject. Okay, let's continue. Let's not go into Boolean algebra right now. Okay, it's one of my favorite thing, one of my favorite subject. That's why I like to talk about. Okay, so any non-zero integer, it will be determined as true in terms of Boolean language. The true and false constants are typed in lowercase rather than uppercase, such as high, low, etc. Okay. All right. Now, pin level constants. What are pin level constants? The digital pins can take two values. Try to understand. Whenever we are getting an output through the digital pins, so the output can either be high or be low. That means in Boolean language, in computer language, in binary version, it's either 1 or 0. Okay. Either it is on or it's off. That means either it is high or it is low, or you can say either it is 1 or 0. Okay. In Arduino, what happens? The pin is configured as input or output. Now, this I don't need to explain you again because I have explained this a lot of times. And try to understand this is the common thing in every code. Each and every code, each and every program, you have this thing, that declaration, right? Okay. So the pin is configured as input or output using the pin mode function. Now the pin is further made high or low using the digital write function. So what we are doing, see, there are two parts. I'll give you an example. Okay, of course, I'll show you the example, but first let us understand theoretically what we are doing. First, we are assigning the job of the pin. For example, input or output. That there are two, for example, there are two pins. Okay, there are two pins. Try to imagine. This pin I'm assigning to be input and this pin to be output. So I'm telling him that please you be the input of it. I'll provide values to you. Okay. And this pin I'm saying, I'm telling that please you become the output. The value that I'm putting here in the input, I should get from you as the output. So I'm assigning the roles, assigning the jobs to them, right? Now, when to be on, when to be off, that is what we assign by the command digital write. Digital stands for digital pin. Write stands for execution of the command. Try to understand. See this? Let me just turn my video off. See at the bottom. See this? See, at the bottom where we are writing digital, right, and there are parentheses. So in the parentheses, we basically give what to do, like high, low. Okay, I'll show you an example. Okay, I'll be showing you an example. Don't worry. Now, high. What does it mean? Okay, the board include two types of voltage pins to provide high value. Okay, which are 5 volt and 3 volt. Now, how I am saying they're 5 volt and 3 volt? I am specifically mentioning about the Arduino board, or rather more specific Arduino Uno. You can see there are two types of voltage input that can be given, or that can be taken. Okay, one is 5, one is 3 or 3.3. So some boards include only 5 volt pin, while other include 3.3 volt. Okay, now which board includes which of them, that you need to revisit or revise our session, second or third session. I don't remember exactly the number, but the types of Arduino session you need to revisit. Okay, or revise it. Okay, now that is nothing to be like memorized or remembered. Okay, you just need to keep in mind. So when you are using it, you can definitely see the configuration of that Arduino board specifically, and you can use it. Okay, it's nothing to be remembered or that sort of thing. Okay, whenever you need 3.3, you can use that board. Whenever you need 3, you can use that board. Whenever you need 5, you can use that board accordingly. Okay, all right. So some boards consist of both 5 volt and 3.3 volts. For example, Arduino Uno R3, which we will be using basically. Okay, primarily and basically we will be using Arduino Uno R3. I'm telling you again and again. So if you are about to purchase an Arduino and program in it, and whatever I'm teaching you are going to execute in it, please kindly buy Arduino Uno. That would be very helpful, very advantageous for you. Later on, when we'll be doing projects, you can also use LilyPad and everything. Okay. Now, the pin configured as high is set at either 5 volt or 3.3 volt. That's an input. Okay. The pins are configured at the 5 volt or 3.3 volt, depending on what? Depending on, number one, for voltage greater than 3 volt, presented at the 5 volt pin. For voltage greater than 2 volt, presented at 3.3 volt pin. What am I saying? It's just a requirement, just the intent of it. Okay, if it is if the work, if the like purpose, or the if the function requires greater than 3 volt, we can give it the connection for 5 volt pin. Okay, and if it is mentioned as required to be greater than 2 volt or something like that, we can use the 3 volt or 3.3 volt pin. Okay, that's the very basic of it. Now, low. The pin configured as low is set at 0 volts. Fine. The pins are configured at the 5 volt or 3.3 volt, depending upon, see the difference between high and low. For voltage less than 1.5 volt, they are presented at 5 volt pin. For voltage less than 1 volt, they are presented at 3.3 volt pin. Okay, these are the difference of representation. That's it. Okay, they are being represented like this. All right, understood? So what is the gist of it? The gist or the conclusion or the crux of it is basically high means the high voltage, which is basically 5 volt or 3.3 volt or 3 volt. Okay, and low means 0 volt, that is switched off. Okay, that's the two values, that's the two configuration for the digital pins. Okay, now LED built-in constant. What is this LED built-in constant, dear students? What is this LED built-in constant? The Arduino boards have built-in LED. Now, I have told you this again and again, okay, time and again, we have used it also. What is that? Without seeing, you can answer. The pin number 13. The digital LED pin number 13 is basically an inbuilt LED, a small LED, which we can use. You can also connect an external LED in the pin 13. I always did that. It was like a bit more fun to do. Okay, do the things that you like basically. Okay, you can maneuver in Arduino boards like that only. You can connect a buzzer and LED together. Okay, and you can use it in such way. All right. Now the particular pin number is defined with the so the pin number is defined with the constant name called LED underscore built-in. Okay. Most Arduino boards have the LED built-in connected to pin number 13, as I said already. Okay, so pin number 13 will be the pin for most of it. Okay, specifically for Arduino Uno. Constant keyword. The name constant or const represent the constant keyword. Okay. It modifies the behavior of the variables in our program. It further makes the variable as read only, right? The variable will remain the same as other variables, but its value cannot be changed. That means if you want a value to assign a value to a certain variable type, and you want that nobody is able to change the value ever further in the code in any time soon, so you need to display the constant variable command. Okay, so once you declare it, so nobody will be able to change whatever they do in the code. Okay, so it will become only read only. That's why it is written. The variable will remain the same as the variable, but its value cannot be changed, of course. It means we cannot modify the constant. For example, constant int a equal to 2, and now if we write a equal to 7 in the code, somewhere in the code, it is illegal, right? Illegal means you will not be charged for it, or you will not be jailed for it. Okay, but you will not be able to modify. Basically, it might show an error. Okay, the constant keyword is considered superior compared to the define hash defined keyword, because it obeys the rules of the variable scope. Why? Because whenever we are defining, of course we are assigning some value, right? But whenever we are defining in the constant keyword, using the constant keyword, dear students, try to understand, even after that, even we try to define it, okay, by using the hash define, it will not be defined, or it will not be changed. Okay, once we mention it under the constant ambient. All right, that is all about constants. See, now if it is not visible, I'll be reading it out, don't worry. There might be a visibility problem. Constant float type variable, we have declared x equal to 5.68. Okay, float y we have declared. Then in void setup, again we have mentioned the rate 9600, and y equal to, it is written y equal to x multiplied by 2, that is x star 2. Okay, we can also use constant in math, you see. Okay, so x value we have declared as 5.68, right? Now if we write serial.println y, okay, it will give the output as 11.36. Fine. Okay, next, the hash define in Arduino is used to give a name to the constant value. Okay, it does not take any memory space, of course, because it's just like writing a name to it. Okay, all right. At the compile time, the compiler will basically replace the predefined value in the program to the constants with the defined value. Okay, that is how it is being used. What is the syntax? The syntax is hash define, and then comes the name of constant value. Okay, where the name of constant, it is the name of the macro or constant to define the value. Okay, and what does the value mean? It includes the value assigned to the constant or macro. Okay, we can call it either way. So for example, you see hash define LED pin 12. So that means it is the correct representation of the hash define. But if we define hash define LED pin equal to 12, if we are writing LED pin equal to 12, okay, or LED pin 12, and after that giving semicolon and ending the structure over there, though both are wrong. Okay, for this hash define, what is the format that has been assigned, dear student? This is a predefined format. Okay, pre-assigned format. We don't need to give an equal to sign. Okay, for the assignment, we can just write the number in it. Okay, all right, I hope the point of constant is clear to you. So this was it from my side. All right, students, I hope you have enjoyed the session and you have learned a lot. Okay, so this is it, and we shall meet again in the next session. Thank you very much for being so patient.